all right. We've got a new week. We are moving on. We are getting very, very close to the end of this unit. We just got a lesson or two here to do, and then we will be doing an online test. So, hope you are learning. Hope you're paying attention. I know those of you guys watching this video, you are doing well on the assignments. So stick with it. Make sure you're understanding, because we're about to get there. Those folks that are skipping the assignment, I'm skipping the video just to save time and do the assignment, not doing so well. May have a little trouble in the test because it's a test, right? All right, let's see what we're doing this week. Let's get into it. All right, starting out today, weighted averages in a triangle. Weighted averages in a triangle. All right, so we're going to look at triangle midpoints. Now, we looked at midpoints a little bit before, but we're going to take it another step. So here's triangle ABC. They've already got it graphed for us. They want us to find the midpoint of each side. Well, this one's pretty simple. We can kind of visually do that, but I want to walk through how to do that in case you have a triangle that's not laid out so nicely. This one actually goes to a point that looks like it's in the middle, but that's not always the case. So let's find the points. This is 2, 1. Right, this is 6, 3, and C is at 2, 7. So got all of our points. 2, 1. All right, so if we are trying to find the midpoint between A and C, to find the midpoint between any 2 points, you add the x's together, divide it by 2. That gives you the x that's in the middle. Add the y's together, divide it by 2. That's the y. That's your new xy. So 2 plus 2 is 4, divided by 2 is 2. We knew that should still be somewhere where x is 2. To what? 7, oops, don't get this. 7 plus 1 is 8. Divide that by 2. 8 divided by 2 is 4. So the point 2, 4 should be right in the middle. 2, 4, looky there. That looks to be perfectly in the middle for our side of the triangle. 2 and 6. 2 plus 6 is 8 divided by 2. That point would be 4. And the y would be 1 plus 3. That's 4. Divide that by 2. So you're basically just finding the average between those numbers. What's the average between 1 and 3? 2. That's the average. It's right in the middle. Average between 2 and 6. 4 is the average. You add them together, divide by 2. You find the average. 4, 2, 4, 2. So that is the point right there, which we could tell visually looking at that where the midpoint is. Let's see. 2 and 6 again is 8. So divided by 2. The average between 7 and 3. 7 plus 3 divided by 2 is 5. So the midpoint is 4, 5. And again, these were all right on points. We didn't have to estimate 2/3 or half or anything. They were right on the points. So we found the midpoint of each side of the triangle. Now what? It says, now I'm going to show you how to draw and label the medians. All right, the medians. And we need the midpoints to do that. That's why we've already gone ahead and we started with those midpoints. So to draw the median, we will take this midpoint and connect it to the vertex on the other side of the triangle. All right, so from this vertex right there to this midpoint right here, we just make a line. That is, oh, I'm off a little bit there. That is a median of the triangle. We do the same thing for this one. We'll start right there. Connect it to this vertex. Okay, and there's 3 medians for every triangle, right? 3 medians, that makes sense, going from one side all the way across to the other. 3 medians. Now, what we notice about those 3 medians is they're all meeting in the same point. This right here is the point where all the medians come together. They all cross at the exact same place. And that is true in every triangle. The medians will do that. This point is known as the centroid. The centroid. Why do they call it the centroid? It's the center. If you had a triangle, you can find the centroid and it will balance right on that point. I had a piece of wood around here. I don't know what I did with it. But you can take that and find the centroid, and it will balance perfectly on that point. The triangle will. That's they call it the centroid for a reason. It is the center. It is the center of balance. It's the centroid. But the medians will show us that. So now it says, after the medians are drawn and labeled, measure all 6 segments inside the triangle using centimeters. What do you mean by the segments? Well, they're talking about from that centroid to each side. So from that point where all your medians meet, we have 6 different segments. And it wants us to use our centimeters and figure out how long it is. So let's start with this one right here. Okay, this one looks like about 1.9 and 3.8. So the longest part is 3.8 and the shortest 0.9, not 3.8 and 1.9. So that's the difference between them. 3.8 and 1.9 between this longer one. All right, let's look at this one here. So the longest section of this appears to be 3.2 compared to 1.6, just barely. You can see that 1.6. 1.6, this longest and that shorter one. So that leaves just this one. So the longest part of this one looks to be right at 3, and that is 1.5. So 3, 1.5. So there is the 3 comparisons of the longer side to the shorter side of the same median. All right, now what do we notice about that? 3 is twice the length of 1.5. 3.2 is twice the length of 1.6. It's 1.6 plus 1.6. 3.8 is 1.9 times 2, or 1.9 plus 1.9. So all of these are at a 2-to-1 ratio. Remember, we had a 2-to-1 ratio the other day where I had 12 M&Ms and I ratioed those out between me and you at a 2-to-1 ratio. And of those 12, I got 8, you got 4. Because for every 1 you got, I got 2. 2-to-1 ratio. So my 2 to your 1 gave me twice as many M&Ms. So 2-to-1 here, for every 1.5 centimeters, this one is twice 1.5. It's 3 centimeters. So that's what we see in these medians. So find the coordinates of the point that partitions A to N. Oh, I didn't label these. So we'll label these L, M, and N. So from A to N, find the point that partitions that in a 2-to-1 ratio. We see that is a 2-to-1 ratio from the measurements that we took. So what is that point? How can we figure out what that point is? Well, N is the 0.45. So how far did the X's go? They went from 2 over to 4. So we have a distance of 2 that the X traveled, right? And this is a 2-to-1 ratio. So we're going to take that 2 and divide it into 3 segments. We'll take 3 pieces, 2 by 3 pieces. So we'd have 2/3 and another 2/3 and another 2/3. And we had all those together. That would be a total of 2. So 2/3 and 2/3. So 4/3 of that X would go before we get to that new point. But we started at 2. So we started at 2, and then we went another 2/3 twice, plus 2/3 plus 2/3. Because if we divide it, there's a 2/3, and then there's another 2/3, and then the other 2/3 goes all the way to the end. So that's how far we went. 1, 2, 2/3, and another 2/3 lines us up with that. So our X coordinate is, well, if we change this to thirds, that is 6/3, right? It's the same thing as 2. 2 is the same thing as 6/3, because 3/3 is 1. So if we have another 3/3, that's 6/3 we have. So 6/3 plus 2/3 plus 2/3. 6 plus 2 plus 2, we have 10/3 as our X coordinate. That's the X of this point. So the X is 10/3, or 3 and 1/3. A lot of you don't like the improper fraction there. You like a mixed fraction. So it'd be 1, 2, 3, and 1/3. 3 and 1/3. So either way, 10/3, 3 and 1/3. How high does it go? Well, it goes 1, 2, 3. It doesn't make it to the 4. So how high does it go from here? It starts at 1. It goes all the way up to 5. So it goes from 1 to 5. That means it goes up 4. So it's going up twice as much for each third of that. We had went 2, went 4. So instead of going 2/3, it's going 4/3. right? 4/3. So if this went 4/3 and then another 4/3, that would be 8/3. But we started at 1, so we're going to add that other 1. 1 is 3/3. So 3/3 plus 4/3 plus 4/3. 3 plus 4 plus 4. The y is 11/3. That would be the point right here. This is the coordinates for that middle point where all the medians are meeting, our centroid. That is the coordinates, 10/3, 11/3. And it says find the coordinates of the point that partitions BL in a 2-to-1 ratio. Well, B gets 2 pieces L. That's going to be the same point. We could do the same calculations, figuring out going from 2 to 6, and we'd only have 1/3 of it past that this time. So that would be 4/3 added to our 6/3, we'd get 10/3. Again, we're going to end up with the same point. So it wants us to do that for all of those, the AN, BL, CM, but we're going to end up with this exact same point all 3 times, just looking at the math. So this is the middle point, and it does divide those medians in a 2-to-1 ratio. Now, we might look at that and say, okay, well, that's kind of cool, but sometimes we deal with an altitude or something, a height. Is that the height? Is that what we're making? Is the height of this triangle? Well, this kind of looks like that might be the height. But if we turn it this way, that's not straight. A height would be straight down. An altitude is what we use for the height. When we're like figuring the area of a triangle, base times height divided by 2 or times 1/2. The height would be straight up and down to figure out how tall it is. Let me show you the difference. Let's look at this. How does a median compare to an altitude? All right, the median is calculated from the midpoint. That means that this is the same distance as this. From B to A and A to C is the same distance because A is the midpoint. And we connect that to the other vertice. This is the median. All right, this is the median that we just did on the other page. That's a median. An altitude would come straight down at a 90-degree angle. This would be an altitude, right? Or what we call the height of the triangle. That's an altitude. This is a median. Those are very different in most triangles. There's also this third line that we make sometimes. This is actually an angle bisector. We looked at angle bisectors earlier to where the angle from there to there is the same as angle from there to there. So this line divides this big angle perfectly in half. So this is an angle bisector. Okay, so that's the 3 different lines that are used a lot in triangles. Either the median, the angle bisector, or the altitude. Okay, and they're different lines, but could they ever be the same line? There is one special case where all 3 of those would be the exact same line. Let me show you. It's right here. The equilateral triangle, right? If these are all 60-degree angles, all these sides are exactly the same length. When we took the midpoint right there, that both of those are the same, or if we cut this in half to a 30-degree and 30-degree angle, or we come straight down at 90 degrees, all of those are the same line in an equilateral triangle, right? All side lengths are the same. So that is the one case where the angle bisector, the median, and the altitude are all identical. Most of the time, not going to be the case, right? Just with the equilateral. There are sometimes cases where maybe 2 of those will be the same and the other one's the different line. But the only time you'll have all 3 of them is in an equilateral. So, wanted to look at that. All right, let's look at one more page here, and then you'll have an assignment dealing with some of this and some review questions. Our assignment, we like to not forget other things because we do have a test come up, so it'll quiz you on some stuff that we've talked about before. So let's look at this. Any triangles medians. Any triangles. We looked at a specific triangle, and we looked at an equilateral triangle. But this goal is to prove that the medians of any triangle intersect at a point. Talk about all 3 medians meet at the same point for any triangle. So we're trying to prove that. So let's suppose that this is our triangle, 0, 0, W0, and AB. Notice we didn't use specific points except for the origin. We said, okay, we could take any triangle and we could translate it to where it has 1 point in the origin, right? So this could be any triangle. Now, the one we had earlier, it was not on the origin, but we could have translated it, and it could have been from the origin, and it would have worked just the same. So this is just saying any triangle, if we translate it where we got it on the origin, and then another point, we could rotate it to where it's lined up on the x-axis. So there's another point at W0, the x being, W would be how far on the x-axis. It could be long, could be short, it could be negative, could be the other way. Doesn't matter. And then the third point being AB, which means it's not on the x-axis. It could be anywhere. It could be on the y-axis. It could be a right triangle. It could be anything. So let's just kind of sketch out just a sample. We would have a point at 0, 0. We would have another one that would be straight across at W0 because we rotate it to be on straight in the x-axis. And then we got some point up here. We'll just draw a point and say that is a B. All right, so if we have this triangle, we can go ahead and complete our triangle just to make it look like a triangle instead of 3 vertices. So we'll take our point and connect all of them. Take that point there and connect. So we have just any triangle because we don't have specific points to give specific lengths. So this is just any triangle. So write an expression for the midpoint of the sides. Okay, so the midpoint would be somewhere, I guess I can put it exactly where it would be just so it looks right. We ended up making that just short of 7. It's about 6.89, so it'd be 3, but about right here would be our midpoint. That looks to be about the midpoint. Okay, so what would be the coordinates of that? Well, the x would be the average between the two. Add 0 plus w, you get w, divided by 2. So that's going to be w divided by 2. Depending on what w is, that'll change. The average between the y's, 0 and 0. It's still going to be a 0. So that midpoint is the point w divided by 2, 0. That is our xy. Okay, so how about this side here? W plus a. Well, let me see. I can kind of draw about where that point would be. 4.8. So it's going to be about right here, somewhere around there. And I'll draw about where this point would be. Let's say it would be somewhere in this area right there. So there's about where our 3 midpoints look to be. But what the coordinates? A plus w divided by 2. So that would actually be what the x coordinate is. A plus w divided by 2, whatever those variables are. And 0 plus b is just b divided by 2. So that is the coordinate there. How about this one over here? 0 plus a. Well, that's a. So a divided by 2. And 0 plus b, b divided by 2. So that is the coordinates of the midpoints for any triangle. Fill in the w, fill in the ab. After you translate it, rotate it to where it sits on the x-axis and it has a vertex at the origin. So we have this case. What does it want us to do next? We write an expression for the midpoint of the sides. So expression would be, a plus w divided by 2, b divided by 2. Write an expression for the point that partitions each median in a 2-to-1 ratio. So what's to find out what would that midpoint be? Let's kind of draw that. So we kind of have some visual to look at. If I actually got my the measurements correct, this should all cross in the same point. Hopefully it's not off too much, and we should be in pretty good shape because we're going to connect all those. Hey, look there. There it is. We do come to one point right there where everything comes together in this point. So we need an expression for that point. Okay, so how far would the x be? This starts at 0, 0. So however far along the x-axis till we get to that point right there, what is that x? Well, we know that this is a 2-to-1 ratio. This is 2 and this is 1. So however far this is twice as long. So we need 2/3 of this distance. This is the x distance. So because it goes from 0 all the way to a plus w divided by 2. So 2/3 of that. So a plus w divided by 2 times 2/3. We need 2/3 of that distance. Well, a plus w is on top with the 2, and this 2 is on bottom. So when you multiply, those would cancel each other out because it'd be 2 over 2. So this would be a plus w divided by 3. So that would be the x coordinate of that. A plus w divided by 3. And then we're going to have a y coordinate. This is going to be the coordinate for that point right there. A plus w divided by 3. Now this would be, how far does it go up? It starts at 0 and goes all the way up to b, right? But this is the 1/3 section. This gets 1/3 of it, and this gets 2/3. So we need 1/3 of the height from 0 to b. Well, it went all the way up to b. B plus 0 is 0. So we know that's the height is b. Whatever b is how far it goes up. Okay, and we're going to take that times 1/3. So that is b divided by 3. That's pretty simple. B divided by 3. So that should work for any triangle. If you translate it to the origin and rotate it so it sits on the x-axis, you could find that median point. And I thought about that. I said, does that really work? I mean, it's all nice here when you're just talking variables that, okay, that could work for anything. So I said, let me actually just put one on a graph. All right, so I did. I put the triangle here. I just said, I'm going to go out to 15, and I picked the point up here, which turned out to be 12, 15. I picked the point and then labeled the coordinates. So I said, let's see, does this actually work? So this is 12, 15, and this is 15, 0. So I said, is this a plus w divided by 3, b3? Is that the coordinates? So a is 15. I'm sorry, a is 12. The w is the 15. So 12 plus 15. 12 plus 15 is 27. And this says I would divide that by 3. So if I divide 27 by 3, I get 9. So is that the x? This is 5. This is 10. This goes right here. That is 9 on the x-axis where that is. Oh, so far so good. This says we take b and we divide it by 3. That'll give us the y coordinate. Well, the b, this is AB. B is 15. 15 divided by 3 is 5. This is the 5. That is the 5. So that is the point 9, 5. This worked. This is absolutely correct. This is the center point, assuming that we translate it to 0, 0 first and rotate it so we're sitting on the x-axis. And like, again, we could do that with any triangle. Then this would tell us the coordinates of that centroid, that point where all the medians meet, right there. So that is it. That's all we're going to cover today. Like I said, we do have a test coming up, so make sure that you understand these practice problems. If not, Mrs. Smith and I are both online every weekday. We're on there for hours. I don't know how many hours a week altogether we're on there, but it's a lot. We're on there at least 10 hours a week and probably a lot more most weeks. And that's just our office hours. Then we can get online. I know Mrs. Smith has a Sign Up Genius where she gets one-on-one tutoring in 1 hour slots. I do that by appointment. If you email me and say, hey, I need help with this, say, when's a good time? We'll hop on and we'll have a one-on-one with you whenever that works. So we're available. Come see us. We want you to understand this. We want you to do well in the test. We don't want online to cause a lot of grief and stress because you're not understanding, because we're still here and just happy to work with you individually and help you all we can. So we will see you next time. Until then, do work you can be proud of.